So another question that you should ask is like, why machine learning? Why has even machine learning emerged? Right? And what changed in few years that machine learning is so crazy these days? It's such a hot field to get into. Everybody's going crazy about machine learning. Everybody wants to become a data scientist. I Gate committee also introduced a paper in data science and artificial intelligence and what is happening. So this was not there since say 2017. If I have to talk about when I entered ISC, it was just picking up. Okay, 2017, deep learning was picking up. There was a very phenomenal paper called Transformers that was released, and thereafter deep learning is continuously on boom. Right before that, all these algorithms that we are going to talk about are there, right? But if I talk about 1970s, right, 1970s or 1980s, when you guys must have not been there, I was also not there. So why was machine learning not there, right? Or what was happening? So see, as I told you, that the machines, right, they learn from the data, right? So now whatever data that you have, right, needs to be in a digitalized form for the machines to understand, right? So for example, if I have to feed in machine image, right, that image should be digitalized, right? For example, if I just have a hard copy of the machine, sorry, a photograph, for example, I don't know if you guys have seen the polaroids, which used to be there. I still have a camera which is a Polaroid. So it gives you a hard copy of the image, right? So machine cannot do anything about it until unless you feed that image to the machine somehow. The machine cannot learn from it, right? Because it doesn't have an eye, or it doesn't have ears like us. So we have to somehow make them see or understand or hear. So how do we do that? We basically digitalize that data, right? So because the digitalization of the data happened in recent years, we are seeing this transformation that machine learning is picking up, and there's a lot of machine learning involved, right? Also because we have a lot of digitalized data. So data was already there. We now have a lot of digitalized data, right? For example, in India, if I have to talk about, before demonetization and before the UPI came in, I think everybody was using the manual currency, right? You were using notes. Now I don't even remember when the last time I exchanged a note with someone, a currency note with someone, right? So because we have done a lot of digitalization, all our things have moved online. If you have to talk to a friend, you will use WhatsApp or you will use any other social media app. But earlier it was not the case. Earlier, you used to pick up a phone, and even before that, you used to write letters, right? So machine cannot, if a letter is kept here, for example, machine cannot read anything, right? Till you feed that data into the machine, that you write that letter on a machine or a laptop, right? So because a lot of digitalization has happened recently, and we have a lot of digitalized data, and there's an abundance of it, we thought that, oh, because now we have a lot of digitalized data, and data is what we learn from, let us try and see if machines can learn from the digitalized data. And that's what we are trying to do. So in past, there was no digitalized data. Let me give you some examples, right? So I don't know how the attendance for you was taken in these schools. So this used to be our attendance register in school, right? So there used to be names, roll numbers here, and there used to be a P marked everywhere, right? Now this machine cannot process. But recently, these apps have come up where you can take attendance, right? So this is some Jibble app that I came across. It is used to take attendance for employees, right? So if now I'm taking this particular app is I'm using this to take attendance of my employees or as students, it'll be very easy for me to look at the data and process it. Meanwhile, if I had data over here, I will have to go through every page and see, suppose a person was absent many times, I'll have to go and see, okay, how many times this person was absent, right? While if I have this data, this is very quick. I can just ask machine to, quickly run an algorithm and do it very fast and tell me which person did not attend the class very often, right? So this was the data before, like you had manual registers where you had to do the entry. This is the data now. So there is a revolution that has happened in data. There's a digitalization revolution that has happened in past, and hence we are able to, feed this data to the machines and take advantage of that, right? So once you are feeding the data to the machines, earlier our purpose used to be, let me store this data in the machine and be able to visualize it. If I have to talk about 2000s or 2004 5, when I was like in fourth or fifth class, the only purpose I used machines was for to store data. I had so much of data. For example, I wanted to store the songs that I was getting from my friends, or I wanted to store those text messages that I was getting from my friends, right? But now it's no longer that case, right? We want to store, but we also want to process on that data, right? We want to search on that data. We want to, uh, get suggestions from our data. For example, suppose you are enrolled in a Spotify premium program, right? You like some song and you don't like some song, right? So now the apps that you have in your phone are so advanced that based on your previous likes and dislikes, they'll suggest you songs, right? Which was not the case 10 years back. 10 years back, you have to basically create a playlist where you will keep all the nice songs that you have. And whenever you listen a song, you keep it separately, right? But now I don't think people create playlists anymore because machines are auto smart and they suggest you songs that they think you will like. So that suggestions, right, are coming from a machine learning algorithm. They have learned to suggest that. They have learned how to uh, take the response from the user, what they like, what they don't like, and then suggest the songs based on some analysis, right? So previously data was not inside the machines. Now we are feeding data to the machines. We have digitalized a lot of data, and hence we are able to, use machines to process that data and learn from it, right? Similarly, I have basically worked in a biomedical startup for approximately 4.5 years. And this was a major thing there. Okay. So these are, if I have to explain you, these are tissue slides. Tissue slides means that whenever, I don't know, in biology, there used to be an experiment where you will drink a very hot stuff and they will scrape off some skin from your inner mouth and they'll show you a tissue slide of that, right? And you will see these structures, right? Onion kind of like these hexagon kind of structures, right? So I don't know if you guys have seen this. So those tissue slides, so these used to be tissue slides, right? And you will view them under a microscope, right? There used to be a manual slide like this. So these are the slides. Okay, so this will be like a slide like this. Um, okay, and there'll be some sample here. And this you will view under microscope, right? And you will see structures like this, right? So there is no way, if I had not digitalized this data, there is no way a machine would have been able to process it, right? But now, the startup that I was working for, they have developed technology in, or they have developed a robotic arm basically, which basically takes this slide and they digitalize that slide. And that's like a multi-million dollar business just to digitalize the slides. Okay. So now these slides get digitalized. So you will see like very high resolution images. And one of this, so I've seen these images and they're like one image can be around 40 GB. Okay. And this basically, you can zoom in so much that you can see every cell. Fine. So these things, right? This digitalization that has happened. Now I can take this slide and I can do whatever I want to do with this, right? Suppose there is a cancer cell somewhere, right? I can see that and I can train my algorithm to detect cancer cell in other of the images, right? So earlier, when they were like a manual slide, this was not possible. Once we digitalize this, now I can use machine to, process large amount of data and to write some algorithms so that they can process this large amount of data and give me insights. Fine. Then again, this is also something that I've seen. So earlier, this is a manual print of the X-ray. This is a hard copy. And I think they must have been storing this, but it was not visualized or it was not given to the users, say 10 years back, right? But now you receive a copy like this, copy like this. whenever you take an X-ray, at least I have received. So now this, right, I can feed this data to the machine, and I can ask very basic things. Tell me if there is a fracture or not, right? Or tell me if there is a hairline fracture or not, hairline fracture or not, which is, which is very minute. It's very easy to miss, right? So I can train my machine to do that task for me, right? Why should I spend my energy looking at this? If a machine can do it, I would very well ask machine to do it for myself, right? So because data was not digitalized before, it was not in the machines, we could not process it. But because a digital revolution has happened, and all the data that we are seeing can be digitalized now, hence that data can be processed by the machines, and hence the machine learning era emerged, or machine learning happened, right? So the digitalization has been very revolutionary, and it has immensely supported the move of machine learning. And also because now you can digitalize any kind of data, there is abundance of data. Like you have a lot of data. And we know that if we have a lot of data, we can learn, right? So now we thought that because now we have a lot of data, let me try and make machines learn, right? And that's how all this machine learning thing started, that, okay, I have a lot of data. I have data in machines. Let me see if I can train a machine to do some task, right? Okay. So now let's come to the things that we are motivated enough or we understand the background of machine learning. Let's see how, what are machine learning algorithms. Okay. So machine learning, first of all, is very different to deep learning. It's not equal. Deep learning is a separate branch of machine learning. It's completely a different branch. Okay. Machine learning that you are going to learn in this particular course are basically called classical machine learning algorithms. So classical machine learning algorithms, because they are very standard. Few things about these machine learning algorithms I will say are they're very interpretable. Interpretable. Okay, which is not the case for deep learning. Interpretable means that whatever your algorithm is doing, right? Suppose is doing some prediction for you, right? I'll basically ask this machine learning to do predictions for me, right? So eventually. So whatever predictions you will do, you can actually interpret why this prediction is happening like this, which is not the case for deep learning mostly. Okay. Deep learning is not interpretable. And a lot of work is happening on interpretability of this deep learning domain. But whatever you guys are going to learn in this particular course is classical machine learning algorithm, heavily rooted in maths, heavily rooted in maths. So obviously maths is very concrete, right? So this is very easy to interpret, to decide like how the machine must have taken the decision, if whatever decision it has taken. So it's a very clean machine learning, right? And these deep learning things that you will see once you get into a master's course, you will see that they're not very interpretable. The explanations are very hand wavy. Okay, they try to explain it. Okay, this must be happening, but then nobody knows what is happening. Okay, so this deep learning domain is kind of a black box. These are not so much. Still, they're like a black box if you don't explain it to somebody who's using it. But you can still go and interpret their predictions. But deep learning is not like that. Okay. So all I wanted to say here was that whatever you're going to look at is a classical machine learning. And classical machine learning is very uh, early stage of machine learning. So it actually developed earlier, where even before the digitalization revolution, only when digitalization happened, we were able to use them more. Fine. So these algorithms were actually developed. Some of them were developed in 1970. I think perceptron was developed in 1970. Only when a lot of digitalization happened, we went back to those algorithms and came and saw if we can reuse them and if we can use them. And we later found out that we can actually use them a lot. Fine. Okay, so classical machine learning algorithms are basically of three types. One is called supervised learning, other is unsupervised learning, and the reinforcement learning. Okay, so we are going to see this and this in our course. This we are not going to see. This is not part of the syllabus. This is something that we'll not cover. Okay. So in GATE DA, you have supervised learning, unsupervised learning, reinforcement is not there, right? So we'll only focus on supervised and unsupervised learning.